Good afternoon, class. I'm going to do some more solving for variables. Seems to be a common thread here in this chapter. We're solving with variables. So I'm going to approach you first with a key concept that we can use now anytime we're going to be solving for variables. And I'll go ahead and point out to you what we're doing here. So step one will be to use the distributive property to remove any grouping symbols. And that could involve fractions as well. You can also work with clearing the problem of any fractions or decimals at this time. Entirely up to you. If you're okay with working with decimals and fractions, then you can keep them as they are. Step two then will be to combine like terms. So the step one and step two will have to be done before we start trying to combine any numbers to isolate the variable. So step one and step two is a very important part of solving for variables. Sometimes the like terms will be on opposite sides of the equation, and that's what we're going to deal with today, is variables on both sides. Steps 3, 4, and 5 will be doing exactly what you've been doing all along, and that would be to after you've isolated those, you'll try to combine the like terms by adding or subtracting, and then multiplying and dividing. Down here, we now have a definition, a new definition called identity. And any equation that is always true is going to be called an identity. So anytime we have the same thing on both sides of the equation, so m equals m, is considered an identity. When the variable equals a number, this is not an identity. This, if you remember, is called a solution. So we're going to refer to that as the solution. So it's an identity if we have two equal things. Down here I have a couple examples. The equation 39 equals 39 is an identity, just like m equals m, because they're the same thing. This also is an identity. Y plus 3 equals y plus 3. It's the same thing, so that's considered an identity, and it's true for every y that you could put a number in here for. Down here, x plus 5 equals 8 is not an identity. It's going to give you a solution of x equals 3. So we get a solution is not an identity. So there's also going to be situations where there could be no solution. And we'll look at some examples down here. We have 3 examples: x equals x minus 1, x plus x equals 2x, and 5x equals 15. So if it's always true, that's considered an identity. Sorry about my writing there. Identity. If it's sometimes true, that's considered a solution. One solution. And if it's never true, that situation is where there is no solution. So over here, we have to determine which one is first going to be the identity. We can see that x plus x is 2x. So we get the same thing we got on this side. So this is always true and is considered an identity. Down here, 5x equals 15, we could actually divide by 5 and get x equals 3. So this would be something that is sometimes true. It's only going to be true when x equals 3. So anytime you get a variable equal a number, that is going to be one solution, so sometimes true. Up here, we cannot have x equal x minus 1. It's not possible. Hold on here for a moment. Timing out of something, so I got to close that out. So anytime we have a variable equal to the same variable and we have a different operation going on over here, this is going to never be true and is considered no solution. And we'll look at some more examples of that. So let's just work with this idea of having variables on both sides. What we have to do is combine like terms just like we've always combined, but we have to get them on the same side. So I got to find a way to get this 4k over here to the other side on 7k. And the way to do that is to identify if this number is positive, then we're going to subtract it to move it to the other side. So the reason why we're subtracting is so we can remove it from this side. So we've removed the positive 4k by subtracting it. So that leaves you, don't forget this minus stays with that number, so that becomes a negative 10. 7k minus 4k, I have to subtract the k's. I can't take 4k from 2. I have to take it from the 7k. So we're going to get 3k plus 2. Now we're at a point where we can just subtract the 2 to remove that 2 from this side. And anytime you're going to subtract a number from a negative number, you're really adding these two numbers together to get a negative 12. We then can divide by 3. That drops the 3 from this side, giving us k equals negative 4. Just like always, you should check your answer. So take k equals negative 4 and put it right in here for k and actually check your answer. When solving for variables, you typically are going to have to work with some word problems. So we're going to go right to the question and try to determine what our variable is going to be and then pull that information out. So in how many months, so months is going to be our variable because that's what they're asking us to find, in how many months will the copier pay for itself. So let's go down to, or up here to the problem and pull out the important information. So an officer or manager spent $650 on a new energy-saving copier. So this is an upfront cost of some kind that will reduce the monthly electrical. So I see monthly here, so we know that that's probably going to have a variable. Monthly electric bill from $112 down to $88. And they want us to determine how many months will it take to make up this $650 that we're going to pay up front. So down here we have the cost of the copier was $650. Well, we're going to have to add to that. We're still going to have a monthly utility bill, and that monthly utility bill is now $88. So it'll be 88 times the number of months that you'll be operating that copier. Well, we want to know based on the old, so we're going to set this equal to the old monthly cost of $112 times per month. So if we would have stayed with the old copy machine, not paid this $650, we would have continued to pay $112 per month. We're now paying $88 per month. We want to figure out how many months will it take to get this $650 reduced down to nothing. So we're going to just combine like terms here by subtracting. So anytime we have two variables on opposite sides, we're going to remove this 88m by subtracting. So that drops it from this side. So we're going to take 112 and subtract 88 and get 24m. So there's a $24 cost difference, and we have to figure out how many months. So we're going to divide by 24 in this problem. So 650 divided by 24 is going to give us 27.08. Well, what this is telling us is that there's 27 whole months in this 0.08 of a month. So really, we're going to be, based on our charges, our monthly charges, we're going to be in the 28th month before we actually make up enough money to have this 650 now gone. So m equals 28 would be your answer. Another type of problem that you're going to be asked to solve today is where you're solving for variables where you have to distribute first. So we're going to have to get rid of the grouping symbols in this case by distributing. So we distribute the 4 to get 8y, so 8 times 2y, plus 4 times 1. So we have to distribute that 4 to both. We're going to do the same thing over here. We're going to take that 2 and distribute it to both of these. 2y minus 26. Now we have to get this variable and move it over here to the other side. To do that, we're going to subtract it. So that removes it from this side, but we have to do that to both sides. So we get 6y plus 4 equals, don't lose your minus here, that becomes a negative 26. Subtract 4, we get 6y equals, remember when we're subtracting from a negative number, we're really just going to add these together. So we get negative 30. Last step would be to divide by 6, and y equals negative 5. Don't lose your negative. So y equals -5, you can certainly go up and check that answer. The last two problems we're going to do today are going to involve the identity and no solution problems. If you remember from our definition, an identity is when we get the same thing on both sides. And a no solution is where it is not possible to get an answer. So we're going to go ahead and distribute this 3 to get 12b minus 6 equals -6b, -6, excuse me, plus 12b. So by rewriting this problem, I'm just going to switch these two, and we're going to get 12b minus 6. We can see that we get the same thing on both sides, 12b minus 6. Anytime that happens, this is considered an identity, and that is your answer for the problem. Now the example down here, before we can actually identify whether this is going to be a solution, an identity, or no solution, we actually have to take this -3m and this 12m and combine them. So -3m plus 12m will give us 9m plus 5. Well, we can see we already have a 9m on this side, 9m minus 4 and 9m plus 5. This is going to be a no solution. You can't take the same number and variable, add number on one side and subtract a different number on the other side and expect to get the same answer. But I'm going to go ahead and go through the steps. In order to get us to understand that this is a no solution, we're going to take this 9m and move it to the other side. Well, we run into a problem. That actually ends up being 0 on both sides. So we're ending up with -4 equals 5. Well, that's never true. So this is an example of no solution. So you could have identified that up here, where you have the same number and variable on both sides, but you're adding 5 on one side and subtracting 4 on the other. So that is a no solution. So go ahead and answer the questions after the video, and then we will go over any questions in class tomorrow.